AI, smartphones, and laptops all rely on one of the most advanced manufacturing processes on Earth.
And most people never think about the chemistry behind them.
Hello everyone, welcome to another episode of the Up and Atom podcast. I'm your host, Eden Austin. This is
Keith Johnson Jr.
And that is
Devin Leone.
Today, we will be discussing the chemistry behind semiconductor manufacturing for AI chips. This includes silicon purification, chemical etching, PFAS chemicals, rare earth metals, and toxic waste. Now for segment 1.
Most semiconductors are made from silicon, which comes from silicon dioxide or SiO2 found in sand.
To extract silicon, manufacturers use silicon dioxide with carbon at extremely high temperatures.
This is a reduction reaction because the oxygen is removed from the silicon dioxide.
The silicon then goes through multiple purification steps because every tiny containment can affect conductivity.
The purified silicon is formed into wafers that become the base of microchips.
Now for an ad from our sponsors.
Tired of cutting things the normal way? Try nano scissors, powered by the same precision used in semiconductor etching. Need to cut a piece of paper? Overkill. Need to cut circuits thousands of times thinner than a human hair? Perfect! Nano scissors, because sometimes regular scissors just aren't enough.
Next, engineers are using photolithography to carve microscopic circuits into silicon wafers.
This process uses UV light, acids, solvents, and polymers.
First, the wafer is cleaned with the solvents and deionized water to remove contaminants.
Then, the photoresist polymer coats the wafer. The UV light causes cross-linking reactions in the polymer. Cross-linking areas resist the chemicals.
Chemical developers dissolve uncross-linked sections, and etching agents remove exposed silicon.
Modern transistors are measured in nanometers, so the chemistry has to be extremely precise.
Chip manufacturers also depend on rare earth metals like neodymium and europium. Rare earth metals have unusual electron configurations that give them their magnetic properties.
They're important for electronics, robotics, and AI data centers.
But mining them often creates toxic waste and radioactive contamination.
What are some other major concerns for other PFAs?
PFAs contain strong carbon fluoride bonds, making them resistant to heat and chemical breakdown.
That stability makes them useful in semiconductors manufacturing, but also dangerous because they remain in soil and water for decades.
Now time for an ad from our sponsors.
Need something that lasts forever? Introducing PFA's Forever Storage. Store your memories, your homework, and apparently yourself. Thanks to incredibly strong carbon fluoride bonds, our product refuses to break down. Ever. Scientists are concerned, but we are thrilled. PFA's Forever Storage. Here long after your great-great-grandchildren. And now, back to our episode. Microchip manufacturing creates hazardous waste and uses massive amounts of water and energy.
Factories use chemicals like hydrofluoric acid, solvents, and industrial gases.
Some of these chemicals can contaminate groundwater because they resist decomposition.
One semiconductor can use millions of gallons of water just every day.
Semiconductors power technology, but making them involves advanced chemistry and has serious environmental challenges.
From purification reactions to PFAS chemicals, chemistry plays a big role in every stage of chip production.
The challenge moving forward is balancing technological progress with environmental responsibility.
Thanks for listening to the Up and Atom podcast. I'm your host, Eden Austin. This is
Keith Johnson Jr.
And that is
Devin Leone.
And we are signing out. Ooh, period. Okay, anyways. We're just like goofing around. Oh! And I'm Eden Austin, and you're watching Disney Channel. I've always wanted to do that.
Please.
I feel like the podcast bro is like a podcast bro where I'm like yeah, dude.
Alright, so let's stay on topic.
Sorry, Melina.
Thanks for listening to Up and Adam podcast. We'll see all of us. We'll see you next time.
We'll see you next time.
Boom.
See, this is cousin telepathy. I need you to like clock in. Gosh. Okay.
Can we start?
Oh yeah. Oh, okay. Sorry. Thing around the camera. Anyways, we have plenty of bloopers. Microchip.
David, stop.
Where are you looking? I like that. Okay. Okay. Let's practice the outro. Okay. I'm your host Eden. Wait. Thank you for this. Wait. And that was wait. I had to. Okay.
They're never the same as the first ones.
Oh my gosh.
Tired of